All right, this video covers AP Calculus Lecture 5.5C. We're going to be working problems from page 355 in your book, and this will be titled Applications of Exponential Functions. So we're going to use a couple of formulas that you might have learned in pre-cal or some other type of business math class. And the first one is the compound interest formula. So that is A is equal to P times 1 plus R over N to the NT. A is our future value. The book uses A. In pre-cal, I used F for that. All right, I don't think A is the best letter for that, but we'll just go with what the book has. So A is future value, P, present value, R is the interest rate, N is the number of compoundings per year, so that'll be given the problem, whether it's semi-annually or monthly or quarterly. All right, you'll have to put that into the formula. And then T is the time in years. Now, if it says in the problem that the money is continuous compounding, then that uses a different formula. A is equal to PE to the RT. So we memorize this in pre-cal as PERT. A is equal to PERT. So I'm going to give you a second to write these formulas down in your notes, and then we will work a couple of example problems. All right, so again we have A is equal to P times 1 plus R over N to the NT. And for continuous, A is equal to PERT. Okay, in your book, on page 355, I'm going to work for you number 54. All right, I hope you can see this on the video, but it's compound interest, and we're supposed to fill out this table based on the information that we have. P is equal to 2,500, R is 6%, T is 20 years. I'm not going to fill out the whole table. I'm going to do one compounding, daily compounding, which would be 365, and continuous compounding. I'll do one of those for you since it uses a different formula. All right, so example 54 on page 355. Let's write down what we know. P is equal to 2,500. R is equal to 6%. And T is 20 years. All right, part A, we're going to figure out the accumulated or future value for N is equal to 1. So A would be 2,500. So we're plugging in 2,500 for P times 1 plus the interest rate, turn that to a decimal, 0.06. divided by the number of compoundings per year, which is just 1, to the N times T, so 1 times 20. Okay, so just plug that into your calculator. Go ahead and practice that. Make sure you can get all that in your calculator correctly, but it'd be $8,017.84. All right, let's do one where N is 365. So this would be compounded daily. So A is equal to 2,500 times 1 plus 0.06 over 365. You may want to put that separately in your calculator, not try to do it all in one go. But if you're adventurous, go ahead and try to do it in one go. 365 times 20. Give that a try, but you should get 82.99.47. And then part C, I want to do continuous. So that's going to be the PERT formula. So A is equal to 2,500 E. We're going to raise E to the RT, so 0.06 times 20. And if your calculator doesn't fail you, you can see that it's by just a little better than 365. The highest interest earned be $8,300.20. $0.09. All right, so that's if you're just solving for A. Or we could also do one where we're solving for P. Let's look at example 60. Right, on the same page. We are also given a table there. And it says, complete the table to determine the amount of money P, the present value, that should be invested at a rate R to produce a balance of 100,000 in T years. So for number 60, we have R is equal to 7%, and it is compounded daily, so that would be 365. Okay, so if we have, what I'm going to do, I'm not going to fill out the whole table because you could do that yourself, but let's just say T is equal to 10. We'll pick that one out of the table. So if we have the formula A is equal to P times 1 plus R over N to the NT, and we want to find P this time, then P, solving for P, is going to be A over 1 plus R over N to the NT. Now it didn't say continuous, it said daily, so we have to use the first formula. So plugging in the numbers, we would have 100,000 because that's our accumulated value or future value. 1 plus 0.07 over 365 to the 365 times 10. So you may want to break that up. Okay, and not try to put it all, do the denominator first, then take 100,000 and divide it by that answer, but however you want to do it, but you should get $49,661.90. So that's what you would need if you're getting 7% interest compounded daily. If you start with that, you'll have 100,000 after 10 years. All right, pause the video if you need to, and we'll work a different kind of problem. Okay, our next example problem, we're going to look at number 64. So it says learning theory. In a group project in learning theory, a mathematical model for the proportion P of correct responses after n trials was found to be P is equal to 0.83 over 1 plus e to the minus 0.2 n. We want to find the limiting proportion of correct responses as n approaches infinity. So no matter what that's saying is, no matter how many trials you do, if you did, what's the top proportion of correct responses are you going to get no matter how many trials you do? That would be the limiting proportion. And then find the rate at which P is changing after 3 and 10 trials. So to find the rate of change, we're going to take the derivative of that function. All right, again, so this is number 64. So we would take the limit as x approaches infinity. Right, this marker's not looking so hot at the moment, so I'm going to try a different one. X approaches infinity of 0.83 over 1 plus e to the minus 0.2 n. So, and this is going to be, n approaches infinity. So if that's infinity, this is going to be the same as 0.83 over 1 plus, since it's negative, it would be 1 over e to the infinity, right? Well, 1 over e to the infinity is just 0. So it's going to be 0.83 over 1. It's like 1 plus 0 on the bottom. So the answer is 0.83. So the best you can do according to this model is 83% correct responses. All right, part B. we want to take the derivative of that. So p is equal to 0.83 over 1 plus e to the minus 0.2n. So let's use the quotient rule. P prime is the bottom, 1 plus e to the minus 0.2n, times the derivative of the top. Well, the top is just a constant, so times the derivative of the top would just be a 0. Minus the top, 0.83, times the derivative of the bottom. Well, the derivative of 1 is 0, so it'd be e to the minus 0.2n times the derivative of negative 0.2n, which is negative 0.2. So times negative 0.2 e to the minus 0.2n. All over the bottom squared, plus e to the minus 0.2n all squared. So getting rid of this whole first term because it's times 0, so p prime is equal to negative 0.83 times negative 0.2, so that's going to end up being a positive, isn't it? So positive there, times 0.2 e to the minus 0.2n over 1 plus e to the minus 0.2n squared. So we want to find p prime of 3. So we're just going to plug in 3. 0.83 times 0.2 e to the minus 0.2 times 3 over 1 plus e to the minus 0.2 times 3 all squared. Got to square that denominator. All right, if you put that in your calculator, you should give that a go. Give it a try. You should get 0.038. So that's the rate of change at 3. All right, so to find p prime of 10, like the book asked, we would just plug in 10 there. All right, so that will help you with a couple of your homework problems, specifically number 61 and 63. And let's go to a very short portion of this lecture on integrating bases other than e. So pause if you need to. And we'll go ahead and retitle this. This part is so short I didn't want to make its own lecture. So integrating bases. So we've taken the derivative in lecture 1, 5.5a, other than e. So there's a formula, and you just got to memorize the formula. If we're going to integrate a to the x dx, so that's some coefficient like 3 or 4 to the x, okay, whatever. It's 1 over the natural log of a times a to the x plus c. What ends up happening, if it's anything other than x, what you're going to do is a u substitution. Okay, you're going to, and I'm going to work a couple of examples where we'll do that. All right, so our first example is example 70, and that is on page 356. All right, so we want to integrate 4 to the minus x dx. So it's not x, it's minus x, so let's let u be minus x. du will be negative 1, so minus dx. Minus du is equal to dx, which is what we need. So we could rewrite this as minus 4 to the u du. All right, now we use the formula. It's going to be minus 1 over the natural log of a, which in this case is 4, times 4 to the u plus c. All right, Now you put u in the problem, you got to take u back out. Okay, so that's going to be, I'm going to go ahead and bring that 4 to the u up to the top of the fraction. So it would be minus 4 to the minus x over the natural log of 4 plus c. All right, usually involves a u substitution and then just plug it into the formula. Let's do one more. I erased my formula, sorry about that. Okay, let's do example. This one I don't. It's not from the book, so we have just 2 to the sine x. I don't think it's from the book. Times cosine x dx. All right, so this is a nice u substitution because if we let u be sine x, then du is sitting right out in the problem. It's cosine x dx. So we could rewrite this as 2 to the u du. All right, I'm not even having to multiply by a negative or a fraction or anything like that. It's really good to go here. So that's going to be 1 over the natural log of 2. 2 is a in this case, times 2 to the u, right, plus c. So that is 1, don't forget that plus c, 1 over the natural log of 2 times 2 to the sine x plus c. And if you want to bring that 2 to the sine x to the top of the fraction and put it all together, it's fine, or leave it like this. All right, that's your examples. Let me give you the homework. So the homework for the first part of the lecture, so all this homework is from pages 355 and 356. You need to do 51A, 53. You don't have to fill out the whole table. Just do 2 and 365 on 53. On 57, you don't have to fill out the whole table unless you're just dying to. 10 and 50. All right, 59, you can also just do 10 and 50 instead of the whole table. 61, 63, those are two that's like example 64 that I gave you. And then the integration ones, and these don't take very long, 69, 71, 73, 74, 80, and 81. All right, let me give you a quick hint on number 80. Okay, so just for number 80, to find the area under the curve, you're just going to integrate. All right, so you're going to integrate from a to b. So in this case, you would integrate 3 to the x from 0 to 3. That'll give you the area under the curve from 0 to 3. So that's number 80. If you've forgotten from chapter 4, we're going to do a lot of finding areas under the curve in the future, but in case you've forgotten, that's how you do number 80. The rest should be self-explanatory. All right, so that is your homework, and I will talk to you next video.